Hello, I'm Adrian, and I am going to talk with you about GraphQL from the perspective of CAPEX and OPEX today. However, before getting directly into that, I'm going to split and pinpoint a little bit about what GraphQL provides underneath the actual GraphQL itself before we get into the CAPEX and OPEX part. There's three basic ways that data has been made available to applications or reporting or individuals for whatever the need is for a company over the last however many years. And one of the oldest ways is, of course, self-hosted data services. And that's basically, in this context, the servers or virtual machines that a company runs and has staff to run for those data services. The next way is managed data services. This is basically the same paradigm. The company is managing the data services, but often gets a staff from a specialized company or something along that paradigm to run those particular data services for them. And then the third, and really the newest kind of way to get access to data services, is the self-service data services. And this is basically the idea that you're able to go into a portal or website of some sort, some type of interface, click a few buttons, and get access to those data services that you need, databases, APIs, whatever it is. Now, I've split out two lists with self-service and self-hosted data services and databases to kind of give an idea of what's out there in the market right now. I left out the managed paradigm just because that sits somewhere in between these options. With the self-service data services, you have things like AWS RDS, Dynamo, GCP BigQuery, Azure, and its plethora of options, where again, you just go into their respective portal, click a few buttons, and you generally have exactly what you want. And there's other ways to get those to through infrastructure as code or whatever the team wants to work through to get those resources. There's a lot of third-party and smaller companies that are working on things and providing these services too, like Hasura, DataStax, Fauna, Confluent, Databricks, etc. And the stalwarts are in the game too, such as IBM and SAP. The self-hosted databases, there's always the relational option, which is still the most prominent option that you see out there. Almost every company has a relational database somewhere doing something, storing lots of different data. Then there's some of the newer options, like the whole NoSQL trend around Apache Cassandra. There's MemcacheDB, Redis, Mongo, Neo4j. Depending on the type of data and whatever it is that you need, they can be self-hosted, and then sometimes they are self-service options. In this, with every single one of those, we have a key paradigm of things either being capital heavy or operationally heavy in cost. And almost always, they correlate accordingly to capital expenditure things tend to have a scaling risk if that initial capital spend is off per se. Like if you spend $5 million on servers and you get those deployed in your data centers and everything's going swimmingly, but then you realize about a year into the project that that wasn't the right amount and you need more, or worst case scenario, you need less. And if that's the case, then you have to go back through the entire acquisition process and either allocate more capital or decide how much loss is actually in that whole process. If done right, though, it can mean a much lower overall cost. However, with the operational focused paradigm, the situation is mostly correlated with that, being that the scale risk diminishes dramatically because you're using something like AWS or Azure or GCP, and with just a few clicks of a button or different deployment, you can shift and change the entire scale of the system that you have and the available resources. However, that then turns into the question of, is the operational expenses going to become cost prohibitive? And everything that I've talked about up to this point is almost balanced, where it's either one or the other. There's usually not a lot of, oh, I can kind of mix and match my operational and capital expenses with this or that data service. The data service that you get usually is one or the other, or at least leaning heavily toward one or the other. However, so how does GraphQL fit into this? Well, that's where things get interesting, because GraphQL provides a couple of very, very key things to current application development in the enterprise and for small business, startups, etc. It did come from the startup world, but it offers some key things to small business and larger businesses that really come into play. One of the key things is a extremely native set of tooling and options for web development. Web development being the preeminent way most application development is done these days. A web developer's tool chest, even if they haven't technically used GraphQL, they're already familiar with many of the notions, the code, the syntax, and the objects of GraphQL. So very minimal amount of training is actually necessary to ramp a web developer up on using GraphQL. And with all of that, there's a little bit of icing too. GraphQL is not exactly tied to a particular transport mechanism, such as it's not tied to HTTP. It could be used in any environment, which means, wildly enough, you could even connect GraphQL stuff up to something like a COBOL or RPG, IBM mainframe database system. It's not particularly only the web it can communicate over. The other thing GraphQL really ties into, with a lot of the tooling and options that are available around it, is very minute individual control and access to the different pieces of data, down to very low-level pieces of individual tuples and elements within even the tuples themselves. So granting access to that, integrating with SSO environments in the enterprise, and then getting authorization and roles set up for that access is something that a lot of GraphQL tools are starting to provide more and more of, whereas some of the other mechanisms that have been used over the years with web development don't always offer that level of granularity, which is something that's clearly necessary within the enterprise. So all those things are available with the GraphQL paradigm, the various frameworks and tooling that are available out there, and then you connect that GraphQL, the GraphQL API services, to your data services or your databases, and you can stitch them together as needed. So that brings us back to this probably familiar slide, since we just looked at one that was very similar, except this is specifically for GraphQL. And again, a lot of the risks and the scale and the questions around CAPEX or OPEX expenditures on GraphQL APIs and GraphQL systems, it's the same questions. However, there's a huge difference. With GraphQL, because you can stitch together your GraphQL endpoints, and you can connect GraphQL to whatever database or data repository or data service, you can really utilize this in a way where you can mix and match your OPEX and your CAPEX, because you're not tied to one singular database or one singular data service. There's tons of tooling out there, such as integration tooling, Hasura, Prism, DataStax, AWS, Azure, GCP. All of them have lots of stuff out there that connects to this and helps you get that figured out. You can, like I said, you can mix self-hosted or self-service environments. So then you're mixing your OPEX and CAPEX as needed. Also, GraphQL makes it really easy to, just span across multiple clouds if you need to. You can pull those into a GraphQL gateway and then provide all of your API services as needed via that gateway. And then, of course, every language under the sun these days, so whatever developer stack, even if you aren't utilizing pure web development as your primary application development environment, the other stacks all have libraries, so there's no problem getting development running against the GraphQL options that are out there. And then, of course, all the existing ETL tooling. So in the enterprise, if you're using like SQL Server with SSIS, SSRS, a lot of integration options there, Oracle reports, etc. So GraphQL provides the option that really can pull things together for a multitude of projects, disparate different teams that might not particularly have data in the same type of data storage mechanisms or databases. It provides a means to bring all that together and simplify the middleware that the application developers would use to build applications for the business. Meaning, simply put, that it makes it easier for application developers to focus on the business need instead of getting lost in the weeds of specific data paradigms or how things are stored in tables or whatever. And it lets the individual division of labor and the focus of the data staff working on the data needs, the application developers working on the application needs, and the business focus to do those things. And then splitting out that as needed between CAPEX and OPEX based on business need again, so that you're not tightly coupled to CAPEX or OPEX and having the respective downside. If you see the downside on either of those creeping up, such as you've put down capital expenditures on something, but then you realize you really want to have operational expenditures on that in case you need to scale back down, you can shift accordingly the underlying systems, and GraphQL enables you to do that more easily. And then, of course, all of this, all the GraphQL options integrate very effectively with existing infrastructure. A lot of the very modern paradigms around infrastructure management, such as infrastructure as code, and it integrates well with older legacy stuff, like real legacy stuff like COBOL, older IBM systems, older SAP systems, and things like that. So GraphQL is something that I strongly encourage people to look at and just give a look at what it could offer you as far as increased flexibility from the business perspective, but also it can definitely make your application developers a lot happier if you provide them that singular layer to deal with instead of many, many different disparate databases and data sources and trying to figure out how to communicate with each of those. So it can really help out the day-to-day and the ongoing projects of a business. So hopefully that's been useful and has put some ideas in your mind about what to look into next. Thanks.